Square and cube roots of rational numbers. Learning goals: evaluate square and cube roots of perfect squares, perfect cubes, and rational numbers. 2. Use the square and cube root symbols to find the solutions to equations in the form x squared equals p and x cubed equals p. Perfect squares. To square a number means to multiply a number by itself. The product of an integer multiplied by itself is a perfect square. For example, x to the power of 2 is equal to p. So you can fill out the table here. We have if x is 1 to the power of 2, the perfect square number is 1. 2 to the power of 2 is 4, and so on. 3 to the power of 2 is 9, 4 to the power of 2 is 16, 5 to the power of 2 is 25. All the way to 15 to the power of 2 is 225. Square roots. The inverse operation of squaring a number is to take its square root. So if we have a number that's x to the power of 2, and then we are given p, then to go from p to the value of x, you take the square root of p, which will give you x. So it's the inverse operation. So here we have the square root of 1. To find out what number multiplied by itself would equal to 1 would be 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4, and so forth. And you can press that on your calculators. So I'm going to clear this. So the square root of 4 equals 2. All the way up to the square root of 225 is equal to 15. So the key thing here to remember is that to square a number, it means to put it to the power of 2 and you get the perfect square. And then the reverse operation, or the inverse, to bring it back from a perfect square to the value of x, is to take its square root, which will give you x. So very similarly, for perfect cubes, the difference is that to cube a number, it means to multiply a number by itself 3 times. The product of an integer multiplied by itself 3 times is a perfect cube. So you can multiply decimals, but then they wouldn't be a perfect cube because it's not an integer. So an integer doesn't include decimal numbers such as 2.5, but they're positive and negatives of whole numbers. So for cube roots, you do the inverse operation of cubing a number is to take its cube root. So when we were squaring a number above, and there's no 2 here because it's implied that there's a 2, but the inverse operation is to square root the perfect square. Similarly, to go back and figure out what the x value is of the perfect cube, you would cube root the perfect cube number. Starting with 1 here, the cube root of 1 is 1. The cube root of 8 is 2. The cube root of 27 is 3. And you can do this on a calculator as well. The cube root of 1 is equal to 1. And then the next number is the cube root of 8. Cube root of 8 is equal to 2. And then you can keep doing that till you get to the cube root of 1,728, which is equal to 12. So now we're going to enter some questions. Question 1, evaluate the square root of 25. So the square root of 25 is, you can put that in your calculators. The square root of 25 is equal to 5. So evaluate the cube root of 343 is 7. Now question 3 and 4 are a bit different because they're asking you to solve for x, given that x to the power of 2 is equal to 36. So we need to undo a squared number here. So the inverse operation of squaring a number is to take the square root. So if I take the square root of 36 and the square root of x to the power of 2, whatever you do on one side, you would do on the other side, x would then equal to, we know that the square root of 36 is 6. Therefore, x is equal to 6. Question 4, solve for x, but the difference here is that it's x cubed, whereas here it was x squared. So the cube root of x to the power of 3 and the cube root of 15.625 is x is equal to, I'll put that in my calculator. So the cube root of 15.625 is equal to 2.5.